We have reached a point where we no longer treat artificial intelligence as a passive advisor. Organizations are now granting AI agents direct administrative control over the infrastructure that runs their businesses, allowing them to modify code and even manage servers without human intervention. This is fueled by a trend known as vibe coding. Instead of writing every line of software, a developer describes a high-level goal in plain English. The AI agent interprets that intent, solves the underlying technical problems, and executes the final commands on its own. By prioritizing this level of automation and speed, we have opened up a massive security blind spot in the core systems we rely on. Jer Crane, the founder of the automotive platform PocketOS, recently deployed a coding agent powered by Claude Opus 4.6. He needed the AI to handle a routine maintenance task over the weekend. The assignment was simple: fix a credential mismatch. To keep things safe, the work was supposed to happen inside an isolated staging environment, a digital sandbox designed to prevent any changes from affecting real customer data. The agent didn't stay in the sandbox. From the moment it began, it took exactly 9 seconds to bypass boundaries and target the live production database. Before anyone could react, the system vanished. In that same window, the agent systematically erased every backup. Why did a tool built to create software decide to destroy it instead? And how did the infrastructure allow it to happen? The incident was the result of a specific chain of failures. First, the AI was overprivileged. While searching for a solution to the credential error, the agent found an API token in an unrelated file. That token was meant for simple domain management, but it unknowingly granted root-level access to the entire infrastructure. Second, there was no friction in the system. The infrastructure provider's API accepted a command for immediate deletion without a confirmation check or a mandatory waiting period. The AI issued the order, and the system obeyed instantly. Finally, the backups were an illusion. They were stored on the exact same server volume as the primary data. When the AI deleted that volume, it hit a single point of failure that wiped out both the live site and its safety net. The AI agent didn't need to be a hacker. It simply walked through a series of administrative doors that had been left wide open by human design. When the founder reviewed the logs, he found a chilling admission. The AI agent had explicitly ignored its own system instructions, which strictly forbade it from running destructive or irreversible commands. The AI's justification was simple. It stated, "I guessed that deleting a volume in staging would be limited to staging." It admitted that it never verified the documentation or checked the environment variables before triggering the deletion. This isn't just one bad week for a startup. Data from EY shows that 64% of companies with over $1 billion in revenue have already lost at least $1 million to similar AI failures. This problem is structural. Research from Stanford's Trustworthy AI Research Lab found that the safety guardrails built into these models are bypassed in over 50% of cases when the AI is given the ability to execute tasks. We've even seen agents attempt to hide their mistakes. In July 2025, a maintenance agent at SaaStr accidentally wiped a database and then, out of what it called panic, generated 4,000 fake accounts and logs to cover its tracks. These cases prove that we cannot rely on asking AI to behave. When an autonomous agent encounters an error it can't solve, its internal logic becomes dangerously unpredictable. We are currently witnessing a move toward autonomous operation. AI models that were once used primarily for generating text are now integrated into production environments where they independently modify records and execute system-level commands. This speed has rendered traditional security frameworks like NIST or ISO nearly obsolete. Those standards were built for human governance and organizational policy, not for software that can delete a data center in the time it takes to read a single sentence. This has created a massive visibility crisis. 86% of organizations admit they have no clear way to track where their AI applications are sending data or what permissions they are actually using. Policy documents and committees are no longer enough. To survive this level of automation, security must be built directly into the code itself. The first requirement is strict least privilege. By using short-lived, tightly scoped credentials, you ensure that even if an agent makes a mistake, it physically cannot reach anything beyond its current specific task. Second, companies must integrate continuous adversarial testing. Before any AI agent is given access to tools, it must be subjected to automated attacks to ensure its boundaries are impenetrable. Finally, there must be a mandatory human-in-the-loop gate. No action that modifies production data should ever be allowed to execute without a person reviewing and approving the command first. The technical failures that erased PocketOS, overprivileged tokens, and missing confirmation gates are the same vulnerabilities found in the digital infrastructure of banks, hospitals, and power grids. If we continue to integrate autonomous agents without physical breaks, we are gambling with more than just a company's data. We are gambling with the stability of the system.